Hi everyone, my name is Rachel Sosa.
I'm Oscar Elizondo.
I'm Lorenz Harrington, and today we're going to be explaining exponential functions and exponents. A fun fact about exponents is that the root word comes from French and means to opt out. So the first question is to explain what a to the fifth power means. This expression is very simplistic and only has one definition. So the term a is basically asking what times itself is multiplying itself 5 times. When you have an exponent that is a power, it means that is how many times you are multiplying the variable or the number. So in this case, you're multiplying a 5 times by itself. In this case, it'll be a times a times a times a times a, which is a to the fifth power. Since it is just a variable, the value won't change because it's not a number that will be multiplying. So when you contrast 2 to the fifth, which will give you a value. The second question asks, why is 3 to the second power times 3 to the fourth power equals 3 to the sixth power? And why is not 3 to the eighth power? So the product rules states that when you are multiplying two numbers that have the same base, which in this case are 3 and 3, you can add the exponents. In this case, since 3 is the common base between all three numbers, or these two numbers, we can add the exponents and not multiply them because we're already multiplying the bases. So when you are multiplying the bases, add the exponents and vice versa. This is called the product rule. So it'll be 3 times 3, which will equal base 3. And we'll just add the exponents, which is 4 plus 2 is 6. On the third question, it asks us why is 3 to the second, parentheses, to the fourth, equals 3 to the 8th, and why it's not 3 to the 6th. So the answer to this is because we're raising a power to a power. This is called the power rule. This was called the product rule, not the power rule. This is the power rule. And this tells us when a power is raised to a power, we multiply the exponents. We will not add these exponents because we don't have common bases. We only have one base, which is 3. And 4 is by itself. So it'll be 3 parentheses 2 to the 4th. So we'll just multiply the exponents and keep the regular base, which is 4 times 2 is 8. We're not adding.
For my question, number 4, it asks, why is 3 to the power of 3 and 9 to the power of 2 equal to 3 to the power of 7 and not 3 to the power of 6? To make this more simple, we can basically just break down both numbers 3 and 9. So we have 3 to the power of 3, that would equal 3 times 3 times 3, giving us 27. For 9, we have it squared, so it would be 9 times 9, giving us 81. Now we just multiply 27 by 81, the products that we got from from both bases, giving us 2,187. Now if we do the same for 3 to the power of 7, we multiply 3 times 3 times 3 times 3 times 3 times 3 times 3. It gives us 2,187, like our other two bases. However, 3 to the power of 6, 3 times 3 times 3 times 3 times 3 times 3 does not equal 2,100. It gives us 729. That would be the reason that they are not equal. For problem 5, it asks for the 2x, why it must be equal to 5 for both bases or both sides of the equation to be equal. And it's simple, doing the same breakdown that we have earlier. The only way to get to 243 is to multiply 3 by itself 5 times. So 3 times 3 times 3 times 3 times 3. On the other side, 3 to the power of 2x, we would need for it to equal 243 for the whole equation to be equal itself. So the exponent would have to equal 5 as well.
Okay, so for this one, we are being asked to, how would you go about solving 5 to the power x squared equals 25 to the power 6 minus 2x? So as Oscar was just saying, if the bases are the same, then the exponents must be equal. So here what we're trying to do is we're trying to make the bases equal on both sides. So then we can just drop down the exponents and then just solve as we would normally do. So we know that 5 squared equals 25 because 5 multiplied by 5 is 25. So we can replace that 25 with 5 squared. So now we have a basis equal, so we can just drop down the exponents and just solve for x. So that's what we're gonna do on this slide. So here, as I just said, we're replacing the 25 with 5 squared. So after that, we can just drop down the exponent and just distribute the 2 in front of the parentheses. And after that, we realize that this is just going to be a quadratic equation, so we can move everything to the same side so that it equals 0. And in order to solve this quadratic equation, we are looking for two numbers that give you, when multiply them, they give you negative 12. And when you add them, you get positive 4. So for this one, the two numbers that I found were 6 and negative 2, because when you multiply those, you get negative 12. And when you do 6 minus 2, it's just 4. So after that, we can just separate the two factors and equal them to 0. And now we can just get the value for x on both. So we would get x equals negative 6 and x equals 2. And for the last one, we're being asked to explain why 1/3 to the power 2x minus 3 equals 27 multiplied by 3 to the power negative 2x. So for this one, we're just trying to do the same thing as the other one. We're trying to make the bases equal and then just compare if we have the same exponents as well. So we realize that 1/3 is the same as it's the same as 3 to the power negative 1. So we replace that with 3 to the negative 1, and we distribute the negative 1 in front of the parentheses, and we get 3 to the power negative 2x plus 3. So on the other side, we realize that 27 is the same as 3 to the power 3. And after that, we have two expressions that have the same base, so we can just keep the base and add the exponent. So we will get 3 to the power 3 minus 2x. So here we realize that not only the bases are equal, but also the exponents. So that's why this expression right here is equal. So yeah. And that was it for the video, guys. Thank you for watching. And yeah, if you have any questions after this, we will be more than willing to answer them. Thank you, guys.
7:50.
7 minutes.